Good morning, sunshines. Page 1 of the practice exam for honors chemistry. For this, names and formulas, you'll want your periodic table. It probably has some notes about things like some of the rules, and you'll also want the back side of that, which is the back of your periodic table. On this one, it says write the following formulas for the following compounds. Not all are ionic. It might help to identify which ones are ionic and which ones are not. Ionics always start with either a metal or NH4 plus, which is ammonium. So this one is ionic, 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 not ionic. So this is covalent, also known as molecular. The reason I'm calling attention to these is they have different rules. Those rules can be found down here at the bottom. A little bit about moleculars, nonmetals to nonmetals, a little bit about ionics, metals to a nonmetal, otherwise it'll have ammonium. The moleculars have the prefixes. That'll be important when it comes time to write the formulas. So, back to this one, copper 2 sulfate. I'd have to find copper, find its charge. It's not going to tell me copper's charge, but they did with the Roman numeral 2. Copper has a +2 charge. Then I have to find sulfate. It's not on the front, it's on the nonmetal ide side. Sulfate, look. There should be some lines maybe here so that I can keep this straight. Hydrogen sulfate. Oh, I put the lines in the wrong spot. Line here to separate the 1s and the 2s. Sulfate is SO4 with a -2. SO4 with a -2. This is what I call a match made in heaven. Some people would think I should crisscross, but a +2 and a -2 make each other perfectly happy. Cu, SO4, that's all I need. Iron 3, chloride, same story. Iron is the type with a +3 charge. Chlorine is on the chloride side, it's got a -1 charge. 3 of those, but only 1 of those, but we wouldn't write it that way. FeCl3. Aluminum has a +3 charge. Oxygen, oxide, has a -2 charge. So when we do that one, aluminum +3, oxide -2, here's where the crisscross comes into play. It's going to take 2 of those because 2 times +3 is a +6, and 3 of those because 3 times -2 is a -6. Yep, now it's balanced, Al2O3. Sodium +1. Chromate, not on the front, it's on the back. I'm going to have to go find chromate. There it is, CrO4 with a -2 charge. So if I have sodium with a +1 and chromate with a -2, it's going to take 2 +1s, 2 times +1 is +2, to balance off 1, -2, Na2CO4. CrO4, it's chromate. Finally, silver sulfide. Silver is a transition metal, yet it's one of the transition metals that's clearly labeled that, oh, we already know its charge. It's +1. These two also, we already know their charge. Those are both +2s. So silver with a +1, getting together with sulfide, sulfur is in the -2, Ag +1, S -2. It's going to take 2 silvers, Ag2S. And when they give you the next one, a covalent or molecular, when they give you the prefixes, it's just as simple. Tri means 3, so phosphorus, there are 3 of them. Penta means 5, so chloride, Cl, there are 5 of them. How do I remember those? I don't have to remember them. They're down here on the molecular prefixes. Next section is naming them. Once again, some of them are ionic, some of them are covalent, and that really makes a huge difference whether you how you name them, because according to this, if they are molecular, or what are also known as covalent, maybe you want to write that, they need prefixes, but the other ones, no prefixes. You don't need prefixes. There's a couple weird ones on the back of the polyatomic ions that might have a prefix, but like dichromate, or dihydrogen phosphate. But for the most part, if you see a prefix, it is a molecular. So FeNO3 taken twice. This is not, this is a metal. This is a metal. So these are ionic. Ionic. Chromium, I look it up, metal, that's ionic. S, that's sulfur, that's not. That is a molecular because it's a nonmetal to a nonmetal. I'll do that one first because that's the one that's going to need prefixes. There's only one sulfur. We'd probably want to say monosulfur, but for some reason, in much the same way we don't say monocarbon dioxide, we don't say monosulfur, we just say sulfur. Now there's 8 chlorines, so I have to let people know that. Octa. And then instead of octachlorine, it's octachloride. They always end in ide. Both these types, molecular, ionic, end in ide, end in ide. Some people have written that on the periodic table. End in ide, the last name. End in ide. Both of those do that same sort of thing. So sulfur octachloride. The next one's Fe, that's iron. NO3, that's nitrate. Iron, nitrate. But that iron is a transition metal. All the transition metals, well, except these 3 that I circled earlier, all the transition metals need a Roman numeral to let you know what the charge of iron is. I'm going to have to do a little bit of dissection of iron nitrate to figure out which its charge is in this case, because there's different types of iron nitrate. If I've got iron with a plus, well, I don't know, tying up with nitrate with a minus one, with a minus 1, but there's 2 of those nitrates, so 2 minus 1s would be a negative 2. There's only one iron. This must be the iron with a iron plus 2 charge. So you have to do a little bit of how did it tie up with nitrate. And once we know how it tied up, we can figure out what its charge is in that instance. Had I simply put FeNO3, or had that been on the test, it would have been iron 1 nitrate because it would be a plus 1 with a minus 1. Ca, calcium. Cl2, don't put di, there's no prefixes, it's simply chloride. Calcium's in a predictable area, it's only plus 2, chlorine's only minus 1, there's no debating it, calcium chloride. Finally, Cr, chromium. OH, hydroxide. But if I check where chromium is located, it's a transition metal. Since it's a transition metal, I'm going to need a Roman numeral. I got to figure out what the Roman numeral is. Once again, if one chromium is tying up with 2 hydroxides, chromium with a plus, I don't know yet, OH with a minus 1, but there's 2 of them, so that's a negative 2. This had to be the chromium 2 hydroxide. Next on this one, balancing the following equations. These ones do require that you put a diagram. How do we go about putting a diagram for them? Well, just draw what it says. An NO might look like an N tied to an O. No colors needed. O2 might look like an O tied to an O. And it yields an N tied to 2 O's. There's no way that we can start off with 3 oxygens on the left and only end up with 2 on the right. So one thing that I know is we definitely have to have at least another NO2. I'm going to draw it and then reassess. Okay, can I start off with 3 on the left and end up with 4 on the right? Nope, that's not going to work. But the good thing is if I draw another NO over here, now I have 2 N's on the left, 2 N's on the right, 4 O's on the left, 4 O's on the right. That is balanced. Now I go back and add the coefficients. There are 1, 2 of these, so put a 2 there. There's only 1 of these. You don't need it there. And there's 1, 2 of these, so put a 2 there. It is balanced with a diagram. Same thing on the next one. Fe, a Cl2 would be a Cl2 tied to another Cl, and it yields an Fe, and I'm just imagining it like this: Cl, Cl, Cl. No way you can start with 2 chlorines and end with 3. So I better just draw another one of these because I can't get rid of chlorines. I can't break them apart. That would violate the law of the conservation of mass. It says matter can neither be created nor destroyed. So we're not trying to change the recipe. What we're trying to do is just trying to figure out how many of everything we needed. At this point then, I'm seeing that now I have 1, 2, 3, 4, 5, 6 chlorines on the right side, but only 2. But they come in pairs, so I'll draw a couple more of those. That is, and then I'm counting up Fe's on the right. There are 2, so I better make another one. Now those aren't in pairs, so that's separate. I made a grand total of 2 of these and 3 of these to make 2 of these. That is balanced. Not my usual way of balancing, but for 2 of those, you'll have to have the diagram. Now, truthfully, if you want to balance it and then just draw the diagram, I'm okay with that. I can't tell what order you did it and don't really care. The next ones, I'm going to make a T-chart over here of C's, H's, and O's. When I'm doing anything that's a combustion, I always go in order of C's, H's, and O's. I'm going to count up the reactant side and the product side. And what do I see? I see 3 C's on the first side, 8 of these, and 2 of these. But on the right side, the product side, I only see 1 of these. H's, I see 2 of these, and oxygens, I see 2 plus 1 is 3 of these. Step 1, fix the carbons, balance them. If I put a 3 here, that will change that. Don't recount everything yet, because first fix the H's. Step 2, fix the H's. If 8 versus 2, if I put a 4 here, there will be 8. Now count the oxygens. 3 times 2 is 6, plus 4 times 1 is 4, 6 plus 4 is 10. I've got everything balanced except I got 5 times as many oxygens on the product side. So I go over to the reactant side and write a 5 there. It is now balanced. These next ones, a helpful hint, when you're counting up these ones, since the OHs look the same on both sides, don't count O's and H's separate. Just keep the O's and OHs together. Polyatomics, if they show up the same on both sides, just keep them together so you don't confuse yourself. I see 1 of these, 2 of these, 1 of these, 3 of these, 1 of these, 2 of these over here, 1 of these, 3 of these. How come I wrote them in a different order than they show up? I like it so that I can go down the line of checking first the strontiums, they match. Then the hydroxides, they don't match. This is that typical, probably a typical 2-3 dilemma where I'll probably want to just shoot for 6 on both sides and get her done. Because if I simply double one side, I'd have 4-3. Coefficients, I'm looking at my OHs. If I got 2 on the left, but 3 on the right, I'm going to triple this side so that I'll have 6 of these. Realize that also tripled my strontium, so I got 3 of those now. And I'm going for doubling the OHs over here because I had 3, now I have 6 of these, but realize that also doubled my FEs. So I fixed the OHs, but now nothing else matches. Next problem, chlorine's probably going to be playing the same game, the 3-2 dilemma. So chlorines, if I double these to get 6 on this side, but that also changes this to 2, and I triple these to get 6 on this side, but that also changes this to 3, it is now a balanced equation. And that ends page 1.